Hi all, welcome to another math video. This one we're going through section P4, and this talks about polynomials, and the main thing in this section is talking about the degree of polynomials and how to multiply them. So basically let's go over a few preliminaries. First, what is a polynomial? Well, a polynomial, I'll just use poly for short, is a string of regular numbers and variables added or subtracted together. And there's one important thing: only positive or zero whole number powers of the variable, I'll just call it x, are allowed. It could be a different letter, but when I say x, that's the most generic variable. So let's look at some quick examples. So a perfectly fine example would be something like 7x to the third power plus 2x squared minus 17. It's just a regular old polynomial with 3 terms. Sometimes we'll talk about the degree of a term. So the degree of the term just means the power of the variable. So for instance, this would be the degree 3 term. This would be the degree 2 term. And notice there's no x term, which would be the degree 1 term. If it's a regular number without an x, we call this the degree 0 term, or the constant term. The degree of the whole polynomial would be 3, because when you talk about the degree of a polynomial, you're talking about the highest degree term. Okay, another example, you could just have something like 85x to the 4th power. It could be a single term, or it could be many. Or you could have something that might not be multiplied out. If you have something like 5x times x plus 3, and I asked you what is the degree of this polynomial, you wouldn't want to jump to any conclusions and say, okay, the highest power I see is 1, so it's a degree 1 polynomial. Instead, you'd want to expand that as 5x squared plus 15x using the distributive law, and you would see that this is actually a degree 2 polynomial. Okay, so let's go back to the learning activity, and the first one is just a simple true or false. It says it's a polynomial of degree 2 with 5 terms. Well, we know that that is false. Why is this behaving so funny? Let's make sure we got the draw on. Okay, there we go. Alright, so this is false. What is the degree? Well, the degree is the highest power, which is this 12x to the 4th right here. So it's really a degree 4 polynomial, because that's the highest power. It's not the one that comes first, but the highest one. Okay, these other ones, we kind of have some exposure to them already, even though we haven't really gone into too much detail. This works kind of like the stuff we did in the radical section. We just pair all the like terms if we want to add. So we have an x cubed term and an x cubed term, so we add those first. So this will be negative 6 plus 17 gives me 11x to the 3rd. Then we have the 5x squared and the 2x squared. Add those together, we get 7x squared. Then the regular x's are alike. Minus 8x and minus 4x is minus 12x, and 9, and minus 13 is negative 4. So, basically, if everything that comes after the regular numbers looks alike, then you can just add those terms. That's what we mean by like terms. So there's 4 different kinds of like terms in this problem. A degree 3 like term, a degree 2, a degree 1, and a degree 0. Alright, the subtraction one is essentially the same, but if you want to drop the parentheses, you just need to remember to distribute. So remember to distribute the negative. Okay, so 17 cubed, x cubed, minus 5x squared, plus 4x, minus 3. And then what I'm going to do is I'm just going to distribute the negative and write these below so I've got all the correct like terms lined up. So minus 5x cubed, plus 9x squared, plus 8x, minus 11. And then we can just add up vertically. So 17x cubed minus 5x cubed is 12x cubed, plus 4x squared, plus 12x, minus 14. Okay, so now we come to actually multiplying polynomials. We can't just use like terms to do that. You may have been taught before the term FOIL. I don't like FOIL very much. I'm going to teach you an acronym that you probably won't like. The reason I don't like FOIL is it only applies to when you have a 2-term polynomial times a 2-term polynomial. So what do I suggest? I suggest you learn ETO-TF-TE-TO-TS. So ETO-TF-TE-TO-TS. That's easy to remember, right? ETO-TF-TE-TO-TS. I actually, one of my professors in grad school is the reason that I use this acronym. And what it stands for is each term of the first times each term of the second. So you see where you get the name ETO-TF-TE-TO-TS. Alright, so how does that apply? Well, FOIL just means first, outside, inside, and last. So you can see when you have something like 5x plus 3 times 2x squared minus 7x plus 4, you're going to get more than just a first, a outside, an inside, and a last, because that second one has 3 terms. So what each term of the first times each term of the second means is we start with this 5x, and we multiply it by every single guy in the first polynomial. So 5x times 2x squared plus 5x times minus 7x plus 5x times 4. And then we keep going, and we take the second term, the 3, and we multiply it by each term of the second polynomial. So 3 times 2x squared plus 3 times negative 7x plus 3 times 4. And we end up with 6 terms. So we took each term from the first polynomial and multiplied it by each term of the second. Then basically we just have to use stuff from P2 exponent rules. Remember, if I do x times x squared, I'm going to get x to the third power because I'm adding the exponents. 1 plus 2 makes 3. And then combine any like terms I have left over. So we have 10x to the third minus 35x squared plus 20x plus 6x squared minus 21x plus 12. Okay, so there's a couple like terms floating around. We've got the 35x squared, the 6x squared, and I'm going to double underline the other ones, so 20x and minus 21x. So this example will end up being 10x to the third minus 29x squared minus just 1x, so I just write x. I don't write the 1, which is common, plus 12. So everything combines, and that's what I end up with. So that is ETO-TF-TE-TO-TS, my favorite acronym. All right. So let's go back to the learning guide, and we have some activities on there. So here's a good good way to do ETOTFT, ETOTS. We're going to do 2x times x squared plus 2x times negative 3x plus 2x times 5 plus 2, now we got to move on to the 3. So, onward to the, minus 3. So we got minus 3 times x squared plus minus 3 times minus 3x and plus minus 3 times regular 5. And then we can kind of multiply the numbers. So 2x to the third power minus 6x squared plus 10x minus 3x squared plus 9x minus 15. And again, look for our like terms. So 6x squared and minus 3x squared, 10x and 9x. So we end up with 2x cubed minus 9x squared plus 19x minus 15. Alright, moving onward, more multiplication. So a lot of these are very similar and they give us lots of practice. So 3x times 2x plus 3x times 1, which is just going to end up being 3x, and then 5 times 2x, and then 5 times 1. And we see what we end up with. 6x squared plus 3x plus 10x plus 5. And then we can put the ones in the middle together. 6x squared plus 13x plus 5. And our binomial is turned into a trinomial. Okay. Another one, this one we can do the same way, but if you remember, this is an example of what I called the conjugate. So you might remember that formula a minus b times a plus b, which we'll also be using next section to factor, gives me a squared minus b squared. So you might be able to jump on this one and say, okay, I know it's going to be 5 squared minus 7x squared, 25 minus 49x squared, but we can do it the long way too. So 5 times 5 plus 5 times 7x, and then plus negative 7x times 5, and then plus negative 7x times positive 7x. And we end up with 25 plus 35x minus 35x minus 49x squared. So you see the middle two terms are just going to drop out. They cancel with each other. And we end up with 25. 25 minus 49x squared. And you could write that another way. If you like writing your higher powers first, you could write it as negative 49x squared plus 25. Both are correct because of the commutative law of addition. Alright, this next one we have here is another example of just multiplying, but what we do is first remember that 2x plus 3 squared, really we can write as two sets of parentheses right next to each other. Like this, 2x plus 3 times 2x plus 3, and then we end up with 4x squared, 2x times 2x, plus 2x times 3, plus 3 times 2x, plus 3 times 3. So we get 4x squared, plus 6x, plus 6x, plus 9, which is 4x squared, plus 12x, plus 9. They, over here, I think for the pencil problem, tell you to use some kind of formula, but the formula is not necessary if you actually just know how to multiply everything out. I always like to just do things from scratch rather than memorize formulas if I can. This one here, x minus 3 squared, will be similar, so we just first write that out as x minus 3 times x minus 3, and then expand using the good old-fashioned ETOTFT, ETOTS. So x times x plus x times negative 3 plus negative 3 times x plus negative 3 times negative 3. Notice I always think of not subtraction, but like adding negative 3. That way I always have pluses in between all my numbers, and I just write the actual signed symbol in parentheses when I do the multiplication so that I make sure I don't have any mistakes. So I get x squared minus 3x plus 9. So this gives me x squared minus 6x plus 9. And we're all done. Pretty straightforward. The last few, we start involving some y's, but really it's not too complicated. You follow all the same rules. So like terms only match if everything after the regular number is alike. So for this one, why don't I just write it so all the like terms are above one another. So 4x squared y is alike negative 2x squared y, so I can combine those two. And then 8xy looks like 5xy, so I can combine those two. And then I have 11 up here and 2 down here. Then I can just add them all up this way. Notice the power matters on the variable, so it's not a like term unless the powers and the letters all match exactly. So I get 4 minus 2, I end up with 2 copies of x squared y. 8 plus 5 gives me 13 copies of xy. And 11 plus 2 gives me 13. Okay, I think this is the last one in this section. It works the same way. What we're going to do is we're going to do 7x plus 5y times 7x plus 5y, and just multiply as usual. 7x times 7x plus 7x times 5y plus, now I go to the second term on the first polynomial, 5y times 7x plus 5y times 5y. And remember, when we multiply these, we can move the letters and numbers around. So just always move all the numbers to the left and multiply them. So 7 times 7 is 49. X times x is x squared. And then when we have x's and y's, just keep them in alphabetical order. So 7 times 5 gives me 35. And then I do xy. The next one, same thing. 35. And then I'm going to write xy because I go in alphabetical order. Now I can see that these two middle terms are actually alike, and I'm going to be able to put them together in the last step. 25y squared, and then to finish it off, we've got 49x squared plus 70xy plus 25y squared. And that is it. We are all done. So I will see you when I do the lecture for the P5 video. Until then, enjoy multiplying your polynomials, and remember our acronym of the day is ETOTFT. Each term of the first times each term of the second. Forget about FOIL. It's one of those bad 4-letter F words. Okay, talk to you next time.